Welcome. Here we are with the warm-up question in the Desmos activity as our introduction for lines cut by a transversal. And we want to review what we know about angle measurements. So when you look at this problem, I hope you notice that these two angles are adjacent, sharing that common side, but the non-shared side creates a straight line. This is, again, what we call a linear pair, because those two angles together do form a line. And the relationship on every linear pair, I hope you remember, is supplementary. So that means when you try and solve for the measure of this missing angle x, you're thinking about the angle 73 we know, plus the angle x that we're looking for in order to make a sum of 180. You go ahead and solve that equation with the 180 and subtracting the 73 from both sides. Your x value comes up as 107. So x then in this case is 107 degrees. Slide 2 here presents another warm-up question for you, again reviewing our angle measurements, as we're going to be doing a lot with angles in this upcoming lesson and throughout the unit. So when you're trying to work through this, I hope that you recognize these two lines which form an X set us up for vertical angles. So remember, vertical angles are not adjacent, but they do point at each other across from the intersection. They point at each other through the X, and those vertical angles are congruent. So your 78-degree angle is also going to be the same measurement for Y as 78 degrees. To finish this out and find those other two measurements, we are going to go ahead and have to use the linear pair. Again, if you look at your 78 and your X, these are adjacent angles, but they sit along that straight line. So you'll have to do a little bit of algebra. The 78 we know, plus the X that we're trying to find, has to have a total of 180 for that straight line that we just looked at. And again, you're going to subtract your 78 from both sides. This allows you to find that x then is 102 degrees. Now again, we've got vertical angles occurring, and remember, every intersection of an x has two sets of vertical angles. So your angle x is also then going to be congruent with angle z. Those are, again, vertical angles, so those are going to be congruent to each other. So what we're going to be working with more so here now, getting into the meat of today's lesson, is talking about a transversal. So what is a transversal? This is a line that cuts through two or more lines. A transversal has to cut through two or more lines. So to give you an idea about how you might see this, maybe you've got two lines, and then you have a transversal passing through as that third line. You can also have multiple lines going on, and the transversal would have to cut through all of those. So these ones are here, the transversal that's cutting through the multiple lines. And as I hope that you can see, this transversal might go through non-parallel lines, or a transversal can go through parallel lines. It applies in either case. Now, we're focusing today on what happens when those lines are cut by a transversal, and there are 5 different angle pairs that we are going to examine and explore. These 5 types of angle relationships here are going to be the vocabulary focus for today's lesson. So the first type that we are going to talk about is the alternate interior angles. So let's take this phrase apart and analyze it. Alternate, think about that meaning things that are opposites or things that are going back and forth. So when we talk about the alternate, we're talking about that in reference to the transversal. So it has to be on one side of the transversal and then also on the other side of the transversal. So back and forth, one on the left and one on the right for it. We're going to talk about interior as the next element of this vocabulary term. And interior has to do with the multiple lines setup. So in this case, where we're looking at this example, we've got these 2 horizontal lines. Those are going to be our multiple lines. They are illustrated as parallel here. They do not necessarily have to be. But so using this with those two horizontal lines to look at the interiors. When you're thinking about that, you are thinking about the peanut butter and the jelly. The interior stuff is the peanut butter and the jelly that you would spread in the middle of your sandwich bread. That's the interior. So with that thinking, when we want to talk about alternate items, we have to make sure that we're looking at an angle that occurs on the left of the transversal and on the right of the transversal. Make sure if you're not seeing that here, when we talk about the transversal, I'm talking about this purple line. So it has to be an angle from the left of the purple transversal and an angle from the right of that purple transversal. The last detail that you need to make sure that you're putting into play with this is that the alternate interior angles cannot be adjacent. So if you're looking at something like angle 3 and angle 4, you're right that they're both inside where that peanut butter and jelly goes, and you're right that it's one on the left and one on the right, but we can't use 3 and 4 because they are adjacent. They touch each other. So when you're looking at alternate interior angles, it would be something like angle 2 and angle 4 would be a pair of alternate interiors. Or likewise, you could look at angle 3 and angle 5 as your alternate interior angles. So those are the items that you can think of. I'm going to take this yellow here out so that you can see that picture just a little bit more clearly without the extra clutter. Those are the two locations that you can look for to find the alternate interior angles. When you move on to slide 6 in your Desmos, we're going to talk about alternate exterior angles. And alternate still means the same thing to us when we talk about it. Alternate is talking in reference to the transversal. So in talking about the purple transversal here that I've just highlighted, has to be one on the left and one on the right of that line. But this time we're talking about exterior. So when you are thinking about and focusing on the exteriors, you're looking at what is outside of those horizontals, what's outside of the multiple lines. So if you're using that sandwich analogy again, where interior was the peanut butter and the jelly between the bread, exterior is where all the crumbs fall off. Those are the things that we're looking for. And again, alternate exterior angles cannot be adjacent. They have to be not touching. So your alternate exterior angles then would be identified as angle 1 and angle 7. Notice they're both outside of these horizontals. 1's on the left and 7 is on the right. Likewise, we can do this again here in a different orientation or to find the other pair when you think about that transversal. And you look for the alternate angles. If we focus on angle 8, that's on the right. So I don't want to use the left angle that touches it on the exterior. I'm using the left angle that does not touch it. 6 and 8 would be your other pair of alternate exterior angles to use. Slide 7 brings us to another vocabulary word. Here we are identifying the same side interior angles. And so same side is going to tell us about the reference to the transversal. So if you are interested in highlighting your transversal, I'm going to make mine purple so that we can really see where that is. These angles have to be happening on the same side of the transversal. In this case, again, we're looking at now interior angles. So you are trying to focus on where the peanut butter and the jelly happens in that sandwich. And we have to be on the same side within the limitations there. So to be on that same side, maybe you're looking at angle 3, and then also to be in between, well, that would be angle 2. See, they're both on the left of the transversal, but they're still in between those two horizontals. They're in between the multiple lines. The other scenario that you could have for this, again, if you consider where that transversal is, and I'm talking about the transversal here that's highlighted in purple, so that we're on the same page. You can also have those, instead of being both on the left of the transversal, maybe you're looking at what you have on the right of the transversal. And so that would be your angle 4 and angle 5 to consider. They're both on the right, but they are not adjacent, and they are both going to be interior. Slide number 8 takes you to a similar sounding item. We're going to do same side again. So that same side is in reference to the transversal. So when you consider your transversal, you're thinking about things that are both on the left of it or maybe both on the right of it. But this vocabulary word, this term changes it up because we're going exterior. So again, remember exterior here is talking to you about the things that are outside of those multiple lines. So in this case, it's outside of the horizontals is where we're looking for the exteriors. Now, again, we're going to look for those items. So if I focus on angle 1 as being on the left side of the transversal and out of the horizontals, then I would also have to stay on the left side of the transversal, but use my other exterior zone to come down and focus on this angle 6. So we could say that angle 1 and angle 6 are same side exterior. Likewise, there's another pair of them that you might encounter. If you focus on angle 8 being on the right side of the transversal, your other exterior angle then needs to also be on the right of the transversal, but it's going to be in the other exterior section, the other spot where you would expect the crumbs to fall off of the sandwich. Slide 9 is going to cover and review the corresponding angles for us. And this one has a lot of different versions that you can encounter it. And so if you notice on your slide, there are 4 spots to draw in or sketch in with this. So when you think about corresponding angles, we're thinking about things that are in the same position. It corresponds because it relates. And so the thing that you want to be looking at here is where those locations are. So for instance, when I look at angle 1, if I think about this intersection where I have 1, 3, 4, and 8, if I think about this as the intersection on a map, angle 1 is in the northwest corner of the intersection. The corresponding angle to that is at my other intersection, also in the northwest corner. So that's going to be angle 2. So angle 1 and angle 2 are corresponding because they're both in the northwest corner. They're both in the top left corner of those respective intersections. It also works very nicely then when you carry it across here and try and think about a different pair of corresponding angles. If I look at angle 8 and try to analyze that, I notice that angle 8 then is in the top right corner of its intersection. So looking at the other intersection, I also go to the top right corner. So that's angle 5 and angle 8 then that are corresponding. So corresponding angles, notice they are both on the same side of the transversal, so that they can be in that similar position, but you've got one as an interior and one as an exterior happening with those multiple lines. You might also be able to visualize this, and it's hard to do this here on the Desmos, but if you can picture that you would kind of cut out this bottom intersection where the 2, 5, 6, and 7 are, if you can picture that you kind of trace that and cut it out, or even better if you use tracing paper on top of it, and then you take that whole sheet of paper and slide it along the transversal, what you've just traced here will line up completely so that you can see that angle 5 and angle 8 then would be in that same position and overlap each other. Farther down on that slide, you can see we've got 2 more sketch areas because there are still other positions that you can find corresponding angles, and I hope you're catching on with that. Angle 3 and angle 6 would be corresponding angles where your 3 is in the lower left and 6 is in the lower left corner. And then the last pair of corresponding angles that we haven't touched on yet would be the 4 and the 7, where 4 is in the lower right corner and 7 is in the lower right corner for that. So these corresponding angles, again, you're looking at them being in the same position at each of the intersections. And just a quick little recap, a quick blurb that don't want to forget about the linear pairs and the vertical angle relationships that we did on our warm-up. Those previous 5 slides that we just talked about, those were all new terms to us for dealing with multiple lines cut by a transversal. But we can still have linear pairs, even though the images and the diagrams that we did for linear pairs and vertical angles were not as complex or didn't have as many pieces, they can still occur in an image like this. So you can have a linear pair happening, maybe it's angle 1 and angle 3. Those 2 are adjacent and they sit along a straight line. You can also have a linear pair going on, maybe you're looking at angle 7 and angle 6. Those 2 would also be a linear pair. And so there are a lot that can come out of this. for any orientation that you're dealing with there in your scenario. And so your linear pairs certainly can be located both along the vertical changes, or they can be located along the horizontal changes, or I should say along the horizontal lines there as you are looking at those orientations. So you could have that linear pair at 4 and 8. You can have the linear pair at 1 and 3. You can have the linear pair at 1 and 8, a linear pair at 3 and 4, a linear pair at 2 and 5, a linear pair at 6 and 7, a linear pair at 2 and 6, and a linear pair and 5 at 7. I'm sure that you can see why I didn't draw all of those out for you, but just keep it in mind that they are all still linear pairs, and so that supplementary rule of 180 still applies. The vertical angles that we can talk about also. Remember, vertical angles are formed and point at each other across the x. So you've got, angle 1 and angle 4 that are going to be vertical angles with each other. You've also then got your angle 2 and your angle 7 that would be vertical angles pointing at each other across the x. Remember then, you could have that other placement. Maybe you're thinking about how angle 3 and angle 8 are vertical angles. They're not adjacent, but they do point at each other from across that x intersection. And also, you wouldn't want to forget that angle 5 and angle 6 are vertical angles. And so they have that relationship with each other as well to still be congruent. So even though these aren't some of the new vocabulary words that we just went through, these rules will still be able to apply through this unit. So we're going to go ahead then with some practice problems. Now, the big difference here is that I've changed the picture on you. All of those previous pictures that we did had you dealing with your multiple lines in a horizontal orientation and then your transversal cut through top to bottom. We won't say it was vertical, but it did have a top to bottom flow. This time, we have changed the orientation of that diagram on you. So what you want to recognize is that your multiple lines, the ones that we previously dealt with as the horizontals, now your multiple lines look like they are vertical. Consider that transversal then, the line that cuts through the multiples, that transversal here, I'll highlight it in purple again if that helps you to see it. So this one you have to think of not necessarily as the sandwich that's laying on your plate. This is the sandwich that you have just picked up and you're trying to get it into your mouth before all of your toppings fall out. So the question asks us to find the relationship between your angle 10 and your angle 11. So these are the two that we are looking at, angle 10 and angle 11. So I want to find out, first of all, if they are going to be alternate or if they are going to have a same side relationship, because those are going to help me to narrow down some of my other choices. And so when I look at 10 and 11, I can see that they are both occurring above my transversal. They're both on the top side of that purple transversal. So that means that we're talking about a same side. So it could be same side interior, could be same side exterior. And remember, corresponding angles also happen on the same side. Linear pairs also happen on the same side of the transversal sometimes, depending upon where they are. So that can help to narrow our choices down. I also want to look at whether these are occurring on interior or exterior. So again, if you're thinking about those multiple lines as your pieces of sandwich bread, are 10 and 11 where you're going to find the peanut butter and jelly before it drips out, or are 10 and 11 where you're going to find the crumbs? Well, those are the insides because that's the peanut butter and the jelly. The 9 and the 13 and the 12 and the 16, those have the sandwich crumbs that are rubbing off on your fingers when you pick it up. So these are same side interior angles. I do hope that you'll take a moment to also explain your thinking and write it down in your own words how we came to this conclusion. As you look at slide 12 then, we're asked to identify another relationship, and this time we're going to be focusing on the angle relationship that we have between angle 15 and angle 11. So we're looking at this relationship between 15 and 11. As you consider this, again, some people like to start out by trying to decide if it looks like these angles are alternates or if it looks like these angles are same sides in terms of that transversal placement. But I do hope that some of you also notice that the angle 15 and angle 11 are adjacent. Remember that these 5 new terms that we just had about these multiple lines cut by a transversal, none of them involved adjacent angles. So it must be one of these previous terms that we had used. Vertical angles are also not adjacent because they have to point at each other. It is the linear pair here that makes them adjacent. And again, remember, the linear pair says that your two angles share a common side, marked there in green, and then the non-common sides create a straight line. That's shown in blue. Again, please pause and write down your thinking to help you remember how you identified this. So slide 13 then, again asking us to practice with this identification. We're going to look this time at your angle 12 and your angle 13, trying to pick out this relationship. So some people want to start out looking at that transversal idea and decide if angle 12 and angle 13 are on the same side of the transversal or if it's on opposite sides of the transversal. When you look at that, I hope that you can identify 13 is below the transversal and 12 is above the transversal with this orientation. So those are on opposite sides. That's going to be some kind of alternate, hopefully for us. Again, remember that your vertical angles and your linear pair can also occur with their angles placed in alternate sides of the transversal. But looking at this more, it can't be a linear pair because 12 and 13 are not adjacent, so that one's now been eliminated. And it can't be vertical angles because these two are not at the same intersection. The vertical angles would have to be something like maybe the 12 and 15, where they're pointing at each other at the same crisscross X. So with those alternate sides, but notice 12 is on the outside edge of this multiple, 13 is on the outside edge of the multiple line. Those are the sandwich crumbs. So we're reaching that conclusion for alternate exterior angles. Again, please pause and write down your thinking so that you have those notes to refer back to. The next item here is going to be determining the relationship between the angles of number 12 and number 15. Well, maybe you have to stop and think about where your interior and exterior zone is. Perhaps you're stopping to analyze where the transversal placement is in relationship to these two angles. However, I do hope that you're becoming more familiar with these angle pairs to see that these two lines form an X and angles 12 and 15 point at each other across the X. That makes vertical angles. I hope you'll be able to explain that in your own words, so you'll be able to reference this later on. Lastly, we've got another example here for angle 12 and angle 9, going back to try and review that. So your angle 12 and angle 9, again, we're going to think about where they are in comparison to that transversal. And if I highlight my transversal in purple to help that stand out for you, think about whether they're going to be on the same side of that transversal or opposite sides of the transversal. I can see 12 is located above, and I can see 9 is located above that. So this would tell me that I have some kind of a same side relationship. Remember, same side interior and same side exterior are obviously happening on the same side of the transversal, but corresponding can also happen on the same side, and linear pair can also happen on the same side of the transversal. Even though the word isn't in their names, that is still where the position is happening for it. So when you consider that, look at the interior or exterior position of those two angles. Think about where the peanut butter and the jelly goes in that sandwich. Well, your peanut butter and jelly would be in between those slices of bread. Hopefully it's not dripping out the bottom of your sandwich. But since that angle 9 and angle 12 were not covered by that peanut butter smear I just put, they're going to be exterior angles. So same side exterior angles here applies. I hope you'll be able to explain that in your own words for your usefulness. And I did want to take one other moment here to draw out a demonstration of corresponding angles for you, just to make sure that you can see that a little bit more clearly. So for a corresponding example, remember that these have to be in the same position. And so your corresponding angles might be something like angle 16 and angle 14. Notice that it's one at each intersection. One is an interior angle, one is an exterior angle, but they are both on the same side of the transversal. 16 is in the lower right corner and 14 is in the lower right corner. And so I know corresponding angles can sometimes trip students up as they're first getting adjusted to them. because it is a little bit harder to visualize with those. But I hope that you have a lot of great success identifying these angles and will be able to put them into practice soon. Have a wonderful day.